Okay, so welcome back, and this is the halfway point of this course. There'd be traditionally a midterm here if there were any exams, but it also represents the time when we switch over from, well, we're still practical, but from the practical stuff to the theoretical, more theoretical stuff, DSAs, data structures and algorithms. So we're going to cover lists and list-based data structures in detail. Then we're going to go over algorithm and algorithm analysis. And then we're going to return to more data structures, tree-based data structures, including binary search trees and heaps at the end. So to start out with, we're looking at lists and list-based data structures. You've been using lists this entire time in Java. Array lists, you may or may not have used linked lists, but you've used array lists. Now what we're going to do is we're going to design those and see how they actually work. In practice, of course, you would never actually design and implement your own list class unless you're required to as part of your coursework. Instead, you'd use whatever's built into the language, like we have, lists, sets, and maps. However, you need to know the details of how they are implemented, because when it comes to algorithms and algorithm analysis, knowing which data structures to use and when and why, that makes, as I usually say, that makes the difference between a computer scientist and what do they call them? Boot camp coder, right? In fact, I've got several stories that we'll talk about when we get to that point. Our motivation for lists and list-based data structures is because they're dynamic. They will automatically grow and shrink as you put things into them or take stuff out of them. You don't have to worry about those mundane details of all the bookkeeping and stuff like that. Not only that, but it gives us an opportunity to leverage those object-oriented programming principles that we've covered. Encapsulation, abstraction, maybe inheritance, and ultimately maybe polymorphism, right? Definitely polymorphism. Also, this entire time when we design this and implement it, we are going to also be testing it. So this iterative design process of going back and forth, testing, designing, testing, implementing, and then in any mutation of that ordering, we're going to be doing that through this entire process. Okay. Let's just remind ourselves of why arrays are bad. Right. You can go ahead and create an array of size 10, but once you've done that, that's it. Once you've created it, it's of a fixed size. It cannot be changed. Right. This is true of most programming languages that do static arrays or even dynamic arrays in C, where you would call malloc to do this, right? You can call realloc and try to expand it or contract it or something like that, but then if it fails, you're out of luck and you have to call a brand new malloc, right? Because if you're running into memory that doesn't belong to you or that's already in use, you're out of memory. You have to create something larger. So not only that, but in a language like C, it's even worse because you have to do all the bookkeeping yourself. You have to keep track of which indices have been used and which ones are free, right? If you delete something or remove something, you have to shift elements down because if I have 5 elements here and I remove this one, I've got to move this one down because I don't want this gap right here, okay? So the solution is to design and implement your own dynamic data structure, right? Of course, in practice, you would use what's part of the library. As part of that, you're going to want to automatically grow or shrink depending on your needs. If it's full, if it's an array and it's full, there are 10 elements in there, and like we have up here, then we're going to have to increase that array size automatically for you, right? Maybe it'll also shrink as well at some point. We don't want to have to worry about the details of how that gets done. That's abstraction and encapsulation in practice. Up to this point, when you've been using an array-based list, an array list in Java, have you had to worry about how it grows or shrinks or how it stores stuff? No, you just used it. In Python, did you have to worry about how a list works? Right? That it's a hash table under the hood instead of an array? No, you just used it. Right? You didn't have to worry about those mundane details. When we design this, we're going to want to be able to add some functionality here. What's some of the functionality that we want? Well, if you remember CRUD, right? Create, retrieve, update, and destroy. Retrieve, update, and destroy. Those are the four basic operations with a table. You need to put stuff in, you need to take stuff out, you need to manipulate stuff in the table. Those are also the four basic operations of any data structure. You need a way to put stuff in, to create, right? In other words, insert or add things to the list, right? You need a way to retrieve. You need a way to get something already in the list, right? The first element, the ith element, the last element, the element that matches some criteria, right? Et cetera, right? Element. There we go. You need a way to maybe update. This is the least important one because, of course, it can always be a retrieve, a remove, and replace. In other words, we're just going to remove, that's the D, that's the delete, and then we'll insert something there to take its place. So that's going to be the create. In other words, the update here can always be in terms of the create and the destroy down here. So we're gonna hold that for last. But destroy, right? And in other words, we're going to need a way to delete something in the list. Right? And as I said before, we're going to start out with an array-based list. And we're going to iteratively design this and redesign it and update it and improve it along the way. We're going to design the interface first. And note this is not in code mode, right? The public methods, not necessarily a Java interface, right? Like that, right? So when I say interface generally in object-oriented programming, I mean the public methods. I don't necessarily mean that you have to define a Java interface, although maybe we want to later on, okay? We're going to design those first. Then we're going to design the tests next. This is an approach called TDD. That's test-driven development. Now, adherence to TDD or strict adherence to TDD would say that you need to design all of your tests first, period, right? And then you can go and implement the actual interface. I'm going to take a more nuanced approach because this is going to be an iterative design. We're going to design a little bit of it, then we're going to test it or make our tests, then we're going to implement it, and we're going to see if those tests work. Then we're going to go back to the beginning and design a little bit more, maybe have to redesign some stuff as we realize, well, wait, we need to separate these out into different functions. So we're not going to follow TDD. We're instead going to follow a back and forth, an Escher kind of thing. We all know Escher, right? MC Escher, the hand drawing the hand, right? It's an iterative back and forth process. The design will inform the tests. The tests will inform the implementation. The implementation then demands that you redesign it in some way, okay? So we're going to go along as we do this, right? I've already set up a new package here. So let's go ahead and start out with a class, right? I'm going to call it my integer array list because initially we're only going to worry about integers. Let's get that done, and then we can come back and worry about, well, what happens if we want to hold a bunch of doubles? What happens if we want to hold a bunch of strings, et cetera, okay? We're only going to worry about integers to begin with. I'm going to call it my integer array list to distinguish it from the Java array list, okay? All right, what belongs in this class? Well, if it's an array list, how is it going to store stuff? It's going to store it in an array. So private int array. I'll just call it ARR for short, okay? There is a holy war between using that syntax versus this syntax. All right. Which do you prefer? Just be consistent. With this one? The other one first? Okay. And then there's another holy war. Should there be a space there? No, there should not. Right? In fact, even if I, yeah. The official formatter there says, no, there should not be a space there. But I see that crap all the time, right? All right, so we've got an array there. Okay. Anything else to do? Anything else? We'll come back to that. Again, we're going to go back and forth on this design and this implementation. All right, let's design the public interface first, public methods. Let's go ahead and start with the create. I want to be able to insert something, okay? So insert or add, right? You tell me, what do you want it to do? In fact, this is why you write documentation first, right? What do you want this method to do? I need a way to put something in the list. Right? Adds the given element. Say, let's even give it a name. X code to the list. ... How? We'll come back to that. So what would you call this? Add element. Okay. Why use two words when one word does? Well, all right, there we go. Add. All right, what's the return type here? Void. Yeah, you're giving me, I'm the list. You're giving me something, I'm not giving you anything. You're just giving me X in order to add it to the list. And it's going to be an integer because it's an integer array list. Okay. So adds the given element where? Where is it going to add it? Okay, adds to the end of the list. There, I like that. Right? In fact, let's take that, and now that we've got the entire signature there, let's redo that because we'll have a parameter X down there. Okay. All right, I'm not going to implement this. Instead, I'm going to put in a to-do implement. If you want to be absolutely sure that you do eventually do this, you can say throw new unimplemented exception. Do this. Right. And I don't think it's, what is it called? Change to unexpected, there should be an unimplemented exception. I forget what it is though. Fine, runtime exception. Right. Runtime exception. Okay, there we go. So that if we ever actually call it without having implemented, we'll remember, right? These are my two reminders, right? Okay. Let's go ahead and go with the retrieve. Get something already in the list. Do we want to get the first element? Do we want to get the last element? Do we want to get the ith element? Do we want to get the element that matches some criteria? We could do all of those things, but which one should we do first? The what? Ith element? Okay, an index-based one, right? So returns the element at the given index. There we go. What would you call this? Get element. Of course, brevity is the wit. What is it? What is Shakespeare? Brevity is the wit of the soul. What? Soul of wit. There we go. Brevity is the soul of wit. All right. So get int index. Now, what's my return value here? Int, because it can't be. I'm going to give you the element at that index. It can't be null. It can't be void there. Right? All right. And for now, I'll just put in a return 0 here, and put in a to-do implement just so that it compiles. Okay? I like that. Okay. Let's go ahead and take care of the destroy. I don't want to come back to, I'll come back maybe later to the update because that'll actually be easier once we've got everything else done. But what about the destroy here? Public, right? Destroy. Sure. Well, what are you actually deleting? What are you actually doing? You're deleting or removing, right? Okay. Removing what? How? Removing the first element, the last element, the ith element, the element that matches some criteria. What? Same as this. Right, let's just be consistent. Right. Removes that element at that index. Removes the element at the given index. Right. Okay. And copy paste that. There. What should my return type here be? Could make it void. Right? Yeah, why? Removes and returns the element at the given index, right? So which one is more flexible? Which one is more usable? no information, some information that you are free to disregard if you want to. I like that, right? And once again, let's go ahead and copy paste that, and we'll implement it later, okay? Now, test-driven development, somewhat test-driven development. Let's go ahead and do our tests next, or at least some of the tests as we go along, right? So let's go ahead and create, now if I had properly set this up, I would have a separate source of, actually we could do that. The instructions are in assignment 0. For that you did want to set up a separate source, that's because you want to keep your tests and your actual code in different locations. But I'll go ahead and put it right next to each other. Let's go ahead and create a class here called my array list, my integer array list tests. Right. I spell it properly. There we go. And rename the file. There we go. All right. So I need to write some JUnit tests here. I could do some ad hoc testing. I do have a demo set up here where we can create a list and then put stuff in and take stuff out and see if it works, right? And we could just print it out to the console here, right? But hopefully we're learning that that is not repeatable, that that's not a good strategy long term. Hopefully we're learning that JUnit tests are way easier to do, right? Well, I mean, there's more of an investment up front, but that investment pays off where I only have to hit this play button and it does it all for me, right? That's where it pays off. So let's go ahead and test. Public void test 01, right? I'll come back with a much better name later on, okay? I do need to bring this in and, okay, I could add JUnit 5 to the build path. Yes, there we go. And it does it for me. Remember that you could also have done that by going over here, right click, build path, add libraries, and then select JUnit 5. Right, but that did it for me. Okay. All right. So how do we want to test this? Let's go ahead and test the first one that we designed, add, right? So first of all, I need a list to test this with, right? So list is equal to new integer array list. And then I'll say list.add 10, list.add 20 and 30. Now, what is your expectation? If you're always adding to the end, what should the list look like after that sequence there? 10, 20, and 30, right? Okay. How do we test that expectation? Yeah, I could, that would require me to basically jailbreak this, right? I could say now that's public just for the purposes of testing. Let's go ahead and break and destroy encapsulation and see if this array is actually equal to, or the first element is 10, the second element is 20, the third element is 30, right? And then after I'm done testing, I'll go ahead and fix that. Now all my tests break, right? I don't want that to happen, right? Ideas? Get the, get the other get, right? So sometimes you have to test two methods in tandem together, right? And that's what I'm going to do, right? Let's go ahead and create some variables here. Int expected and actual, right? Now let's go ahead and say list.get the first one, 0 indexing, right? And that will be my actual. That's for the first one. What's my expected then for the first one? 10, right? And now I need to assert that they're equal. Assert equals expected and actual. I think that's the order. Let's go ahead and bring this in from assertions. Yeah, and then this is expected actual. I got it right. Right. So should we only test the first one? Let's test the second and third. That should be 20. Don't copy pasta, but it's okay in this case as long as you remember to actually change everything, right? Okay. There. I like that for now. So let's go ahead and rename this. Test, add, and get. Right. All right, and then we can document that. Okay. First of all, is it going to pass? I'd be very surprised if it did, but it's not. Why? Because it says do this, right? Okay, so let's come back over here and do this now, right? So let's implement this. All right, how are you going to add an element to the array, to the end of the array? I need to put it in somewhere. So this is where we realize, oh, we've designed the interface, we designed the test, now we need to implement it. Maybe we need to come back to the design here. Because to do, was there anything else that we need to keep track of? Size. Right? And I'll keep that there just in case we need to do anything else. Right? So suppose that you already had, suppose that you had nothing in there right now. Right? In other words, the size is 0. Where would you end up putting this then? At the 0th index. Right? What if there were 2 things in there already, 10 and 20? The size is 2. Where would you end up putting this to be at the end of that array list? Or at the end of that array? 2, right? Which in general is going to be this dot size. Always use this, even if it's not necessary. You should just get into that habit. Right? That's the best practice there. All right. I'm going to leave that to do in there because I don't know if it works yet. Right? Yeah, would you say what? Yeah, okay. Oh, good. Okay. Update the size. Jumping ahead. So this dot size plus plus. Okay. There's still plenty of problems to come back to and fix. Right? All right. So what else? Now I want to do get now. Right, so how are we going to implement this? This dot array dot or of index. There's the element. What do? I just simply return it. So are we done there? I don't know. I'm going to leave it until we're done testing, right? And done designing. Okay. Let's come back over here now and see if it works. All right. Nope. Cannot store int array because this dot array is null. That's a wonderful message. It's telling me exactly what's going on there, right? Was this ever initialized? Was this ever set? We never did a constructor. So let's make a constructor. Public, my integer array list. Let's go ahead and make a default constructor here. What should it do? Well, initially, what should the size be? You haven't put anything in it, so 0. Right? What about this array? What did we do over here with arrays? We just made them of size 10. This dot, or new int array of size 10. Now that's the size of the array, not the size of the list. You can think of this as more of a capacity. It's able to hold 10 things in there, but there are 0 things in there right now, right? What happens when we insert 10 things and we want to insert the 11th thing? It's going to break, right? But for now, my tests all pass. Right? So we're good with it? Ship it? No. We only have one test here that tests 3 things. What should I be testing? I should be testing 11 things. Right? So let's go ahead and have another one. Get and add and get bulk test. Okay. All right, and let's go ahead and create a new array list. So copy paste this, say 11 times, 20 times, 100 times, 1,000 times. No. Go into a loop for int I equals 10. I is less than or equal to, let's go up to 1,000, 100 things. I plus equals 10. We're going to insert 10, 20, 30, 40, all the way up to 1,000 by tens. Okay? List.add I. That takes care of that. Actual and expected. I'm not going to copy paste, copy paste, copy paste. Instead, what I'm going to do is I'm going to go into another for loop. For int I equals 0, I is less than the size of the list, I plus plus. Well, I know what the size of the list here is because I just inserted 100 things, right? I went up to 1,000, but by tens, that's going to only be 100 things. So I could say 100 there. Is there a better way of doing that, though? Yeah. So, once again, my testing has informed my design, right? So back and forth. Don't be one of those TDD freaks that says you have to do it this way, you have to do it this way. No, it's a back and forth kind of thing, right? So let's come back over here and add that. Public int size. Return this dot size. Right? Okay. To do documentation. You can write it. Returns the size of the list. Right. The current size of the list. Okay? I like that because then we can actually use it over here. This dot size, or not this, but list dot size. Okay? All right, so what's our expected then? So if I, here, let's get the actual, I guess. Actual is equal to list.get sub I. And then I need to insert that those, assert that those are equal. What are you expecting on the ith iteration of this? For 0, it would be 10. For 1, it would be 20. I times 10 plus 10. Okay. Is there a better way of writing that? Math majors? I plus 1 times 10. There we go. I like that a little bit better. There we go. All right, and assert equals, there we go. Now, of course, it's going to fail here. Why? Because when we get to that 11th element, right, index 10 out of bounds for length 10, right? Because I'm trying to insert it at the 10th, index 10, which would be the 11th element. Back to the drawing board over here. To do implement. We need to determine, is it already full? If the array is already full, then increase its capacity. Okay? I'm still going to leave the to do in there because we're going to come back and do more stuff. If it's already full, if is full, then increase capacity. Actually, oh, this is get, sorry. Where am I? I know I want to be up here. There we go. All right. How do I determine if it's full? If this array is equal to the size, or this dot length, sorry. Yeah, dot length. Right? All right, and equals equals. There we go. All right. In fact, that sounds like we might end up having to use that multiple times, right? In multiple places, maybe, right? If I do end up having it in multiple places, wouldn't it be easier if it were in a method? Right? For example, like round descents, or do I want to copy paste, divide by 100, multiply by 150 times? Right? No, it needs to be a function. For now, though, it doesn't need to be a public function. Right? There is no such thing as it's full. Right? You're asking a question as to whether or not this internal element is full. Right? So I'm going to make it private. Is full. Boolean is full. Unless there is an absolute if a very good reason, VGR, right, to make this into a public method, I'm going to keep it as private for now. And I'm going to return that expression right there. Don't write an if-else-if statement. If you've already got this expression, and if that's true, then you return true. If it's false, you return false. Just return the expression there. Okay? Now that I've got that, I can come up here and have more English, right? If this is full, then I will increase its capacity, right? It's basically almost exactly the same words up here, but I don't have to have that cruft anymore. And it's more English oriented, right? And instead of this expression right here, right? All right, increase its capacity. How? Is there a realloc for new? Nope. So I'm going to have to create a new array. Int, new ARR is equal to new int. How big should it be now, though? Okay, so this dot size plus 1. So if we have 1,000,000 elements, I'm going to end up doing n1. 1,000,000 elements in 1, n2, n3, right? You'll find that that's going to be extremely inefficient. Right? So let's just go ahead and go up by tens. Now, you could go with like what TCP/IP does, and they will, on successful transmission, it doubles the transmission, and then it doubles it again, and it doubles it again until it loses packets, and then it pulls back. It increases exponentially, but then it pulls back linearly, and it turns out that in practice, that's the sweet spot, right? So if you really want to do that, you can do it here, or you can come up with some dynamic way of doing this. I'm just going to go ahead and keep it simple. Add 10. It's probably better to do this dot array dot length because they're equal, right? So whatever the capacity of the old one is, and then we'll add more room for 10 here, right? and then I need that right there. Oh, and then Holy War, do you prefer that or that? At least when we're doing this, I prefer like this. No? Okay. Your mileage will vary, whatever.
It's a type, it's an array, it's an integer array. So
Yeah, the argument for doing it over here is that it's keep the types together. The argument for doing it over here is that's how you use it. Right? That's where you put it when you want to actually index it. So right? Half of one, or 6 of one, half a dozen of the other, whatever. All right, so what is in there right now? Nothing. Actually, lots of nothings, lots of zeros, right? In fact, there are going to be this dot array length plus 10 zeros in there, nothings in there. Right? I need to make sure that I'm not losing those old values, 10, 20, and 30 that might have been in there already. Right? So I need to copy them over. For int I equals 0, I is less than this dot array dot length, I plus plus, lots of code to say that new array sub I is equal to the old array sub I. Once you've copied them all over, you can say that this array is equal to the new array. Right? And then, if this were a language like C or C++, clean up the old array, question mark? Yep, free the old array, and you'd have to have another reference to it so that you didn't lose it, right? Or in C++, it would be delete, the delete keyword. This is Java. Do we need to worry about it? Nope. Automated garbage collection. Okay. Does it work? Green. Right? Green is good. Right? But lots of code is not. What's the DRY principle? Don't repeat yourself. When you are solving a problem in engineering, what's the first question you should ask yourself? Has it already been solved? Right? And yes, it has. This dot array is equal to arrays dot copy of this dot array, and then we will say the new size is going to be this dot array dot length plus 10. And if you read the documentation, it will pad it out with 10 zeros at the end after having copied over everything. Right? And it's probably a hell of a lot more efficient than what we're doing here, because it probably is like some native mem CPY or something. Yep, it's doing some system.array copy, and yep, it's native. So it's probably, literally, it's probably doing a malloc and a memcpy under the hood here somewhere. We can never hope to reach that performance with any code over here, right? Because it's system level code. Right? That is much better. Okay. Insert it now that we've got it's full, but we created something that is a little bit larger. Now we've got enough space for it. We update the size and we return. I am fully convinced that after having inserted 100 elements, that it works. Right? And what else have we tested, by the way, by doing that? Well, we did get and add and get at the same time, but now we've also done size. Right? Let's come up here and do that again. What should the size be after you've added the first element? Assert equals 1 list.size. Right? What should it be after you've inserted the second element? And the third, 2 and 3. Also make sure that what happens with an empty list should be 0. Right? Just by adding a few lines of code here, I'm adding more, not more tests. There's still only 2 tests technically, but some of these tests test multiple things. Right? Now, strictly speaking, you should separate those out because you want unit tests. You want them to be actual units. We are actually testing multiple units here: the size, the get, and the retrieve, and the add method here. Right? So strictly speaking, you should separate these out. Okay? But there's really no way to separate out the add without some sort of get test here, because you don't know how to do it, without ripping open the guts of this thing and pulling out the array to make sure that it works. Right? And you can do that, but it's going to require reflection and way more code than I'm willing to write right now. Right? All right, so that looks good. That looks good. Before we move on, though, is there something that we're not testing here and we're not really thinking about? We could do, so let me come back over here and we could have a contains method, right? So actually we'll come back at some point and do that with just these methods. And is there something that I'm missing? Let's go ahead and create another test down here. Not the bulk tests, but validity tests. Test validity, right? And validity in this sense means that what if I had a list and I asked for something that shouldn't exist? It's an empty list, right? Should I be able to get the first element? No. Should I be able to get the negative 10th element? This isn't Python. Should I be able to get the 4000th element? No. So test validity, right? Test index bounds. Okay. So should this work? No, it should not. Right. Oh, it does.
We don't assert it.
Yeah. Oh, yeah. So what does this end up getting? Yeah. What's the element at index 0 right now? It's 0. So you're getting something that you shouldn't be getting here, right? So let's implement this and think about what should happen. If you give me a negative index, or you give me an index that's too big, then what do you want to happen? Throw a new, I don't know, illegal argument exception. I like that. Index plus index doesn't make sense for a list of size and then plus size. This dot size. Okay. Nice helpful error message there. Now what should that question mark be there? Okay, so if they're 10, 20, and 30, the size is 3. So this dot size? Okay, -1, or another way of writing it? I don't know. We do not minus, because then we'd actually decrement it, and right? Let's go ahead and go greater than or equal to. Right. I don't know, which one do you prefer? Equal to? Okay, there we go. Right. So you asked for something that didn't exist, we're going to throw an illegal argument exception. Now, over here, it's going to fail because it throws that illegal argument exception. The way that we deal with that I had to remind myself at the top here because I forgot about it in the main section, but you assert throws, and then what you need is an illegal argument exception, the type of exception that gets thrown, and then what you do is a lambda expression, because this is the way of doing it in JUnit 5, for that list.getZero. Right. Dot class here, sorry. Oops, there. And I need to import this from assertions. There we go. There we go. So this is a way of testing. I'm about to do something that I know is wrong, and I want to know, did it successfully throw the exception back in my face? And 3 out of 3, yes. What else would you want to test here? Okay. Could you do that? Could you say hello? There's the ultimate tester, the compiler, right? The compiler says, nope, that can't happen, right? Because that's not an integer. So we don't need to worry about that because it wouldn't even compile. But what if I add 10 and I'm now asking for 0? Assert not throws? Darn it, now I'm gonna, JUnit, assert not throws? Assert does not throw? Or no exception or something. That no exception is, it does not throw. Yeah, there we go. Does not throw. It does not throw, not throws. There we go. And there we go. Oh, come on. It's not gonna work. Oh, is it just one argument here? I have no idea what that string should be, but we'll go ahead and leave it like that. Hopefully that works. Nope. Okay, fine. String. All right, I don't remember what to do there. All right, I'll have to come back to there. All right? But there is a assert does not throw, right? Let's test some other things here. Now that we've added one thing, of course we know that that's going to be valid, but what's never going to be valid? Negative 10. We've only added one thing here, so what should not be valid? Anything large, so let's just go ahead and go with 100 here, right? Strictly speaking, you should separate these into 3 different tests, because one, it's more impressive, right? Index out of bounds exception 0, 1, and then 0, 2, 0, 3, right? 0, 2, 0, 3, and then you're testing these things in isolation, right? Strictly speaking, that's what testing should be, but also you get extra credit for it, because now I've got 3 tests instead of just 1, right? Let's go ahead and take out this. I'll leave that there, but to remind myself I should look that up. I don't need that anymore. And then we'll add one, and then we'll still do that one. We'll add one, and we'll still do that one right there. Right there. Now you get 3 for the price of 1. Right? And how many tests are now passing? 5 out of 5. Right? It's way more impressive now. 5 tests. Right? Okay. Actually, I should take that out too. Right, there. Now it's actually just testing one thing. Okay. All right. Let's come back over here. Well, if that's necessary for get, was it necessary for add? Should I be checking index bounds here? No, there's no index to check. Right? You're just always going to add it to the end. The whole point of doing a dynamic data structure is that it's going to grow infinitely. Right? If you ever do run out of memory, that's not something you can test. Right? That's not something you can you can recover from. Right? That's the Java virtual machines problem at that point. Right? But now that I've got all that information and all those lessons learned, let's outline remove. What's the very first thing I should do? Remove at index. So test bounds. Right? 2. Then what should I do? Well, if I'm going to eventually remove it, save off the indexed element to return it. And then 3, remove it. Now let's think about that. What if there was 10, 20, 30, 40, and 50 in there, and I want to remove 20? What should it look like after all of that? 10, 20, 10, 30, 20, 40, 50. Right? In other words, it should not look like this. There shouldn't be a gap in there. So what you're going to end up doing is you're going to end up shifting everything down. Right? So remove it by shifting everything down, starting at index. Okay? There's my outline. Test bounds. What should I test? Copy, paste. Right? So you can remove 0 if there's a 0. You can remove 1, 2, 3. If there are 5 elements in there, 0, 1, 2, 3, 4 are all valid things to remove. But what's not valid to remove is the size up there. I don't even have to change my error message here, do I? Index does not make sense for list of size, whatever. Okay. Save off the element. So int result is equal to this dot array sub index. I know that that will work because if it didn't, then I would end up throwing this exception here. Okay. And we'll return it. Right. Now, how do I shift everything down? For loop. Start at the one that you're going to remove, and then take the one right after it and replace it down there. Then go up here and take this one and replace it there. And do that over and over again until you get to the second to last one, because do I need to remove 50? If I copy 50 down over here, just leave it alone, right? Okay. So for int I equals index, starting at index, I is less than or less than this dot size minus 1, because we're going to stop short by 1, I plus plus. This dot array sub I is equal to this dot array sub I plus 1, the one right next to it, plus 1. Oh, and then not return result. That's what I should have done there. Can you think of anything that might go wrong here? Well, you still have a 50 at the end, but so what'll it end up looking like? There we go. Now, how do we get rid of that 50 without getting rid of it? Well, I mean, I could change it into 0. I can't change it into null because these are all primitive types. Right? Can't change it into XX because there's no such thing as XX. Right? Just leave it there. But my resulting size should be 4 now, right? So after you've shifted everything down, what do you do to the size that we did over here? We said increase the size. Down here, what would we do? Decrease the size. Right? And then return the results. Okay. All right. Test delete. Public test. Public void test add. All right, we're gonna end up testing add, delete, and get all at the same time, right? Test delete. Here's a really quick way that we could do it. We could steal this up here, add them all, right? And then I need a list. Sorry. Right. Add 100 things. Then for the same for int I equals 0, I is less than x, 100, I plus plus. We'll go ahead and fix that for now. List.delete. All right, no, list dot, what was it, remove? Remove. The element at the, I don't know, 0th index. In other words, we're always going to remove from the front. Test delete from front. Right? We're always going to remove. Now, how do we test that that actually worked? The list should be empty at the end, right? So, list dot size is equal to 0. Right? So assert equals. That's the expected. The expected should be 0 at the end, and then the list dot size should be like that. Right? But we're actually not testing a lot along the way, are we? Right? If I have 5 things in there, 10, 20, 30, 40, 50, and I delete 10, what should I expect it to look like afterwards? 20, 30, 40, and 50. Right? So let's test that all along the way. That if you remove the first one, then I'm going to expect that assert equals whatever it is, list.get the 0th element is equal to that after you've removed the first element, right? What's that going to be? I plus 1 times 10, but careful, because we've already removed it, so it should actually be the next one, so I plus 2. Right. Okay. Now careful here. Are we going to test that 100 times? Once you've removed 99 of them, what should be the last one? Once you've removed once you've removed them all, are you going to be able to assert that nothing is equal to 1010? No. So we'll stop short at 99. Or we could rewrite this entirely. While, instead, list dot size is greater than 0. We'll remove the element and assert that the next one is, okay, I've lost I though. All right, so there's an argument. I need the actual value there. I could take that out and make another variable, but I like that, right? And then we need to remove that last one. So we need to remove that last one, and then we need to assert that it's actually empty, right? All right, let's go ahead and save this, and come on, please, please, please. Yay, 6 out of 6. We only have 2 minutes left here, but what's something else that I should test? I was always testing from the front, from end, right? The back. What's another thing that I could test? Yeah, unfortunately with randomness, now you can't expect, or you don't have any expectations, right? If I randomly generate I and say remove that ith element, right? Then how do I know that it worked, right? Test delete from front and back though. Like, so I'll do one in the front, then one in the back. one in the front, one in the back until I get to the middle. Right? So we could do something like that. Right? I will leave these both as to-dos for you. Right? And instead, we'll come back next time and continue with some secondary functionality. Because at this point, I've got a full list already, right? Except that, what is this list good for? Integers, right? What do I want it good for? Everything, anything, right? And that's where we'll start on Wednesday, by parameterizing it. Okay?